All right, grade 12s. Well, welcome. I know you missed me. And I've got this little simulation here to show you. I know I showed it to many of you in grade 9, but anyway, the next unit is static electricity, and it's very different from the static electricity that we've done in the past, but the basic theory on how it works is unchanged. So anyway, look. With electricity, we're going to skip the whole ancient view of electricity and everything else. The first discovery of electricity was static electricity. And so it's pretty simple. Okay, here I have a neutral balloon. It's neutral because it has the same number of positives and negative charges. Okay, so that's what makes something neutral. Now here we have a sweater over here, it's neutral also. Here I have a wall on this side, that's neutral also. And the deal is that the balloon has a high affinity for electrons because it's made of rubber, okay? And the wool in the sweater has a low affinity for electrons because it's just a physical property of the rubber and the wool, right? Like these are some of their characteristic physical properties. That rubber has a high affinity for electrons, for example, is one of its properties. All right, so look. If I just take the balloon and just sort of rub it onto the sweater, then what happens is, on purpose, I'm not going to pick up all the electrons because that never actually ever happens. Okay, you're always just picking up a portion of those electrons. Okay, from the thing. In fact, here it's very much exaggerated. Okay, there's not just 3 electrons left in the sweater. And the sweater has many trillions of electrons. Okay. Like every atom is surrounded by electrons. You're only moving a few of those electrons, and so it doesn't take very much though. Even a loss of a few electrons is enough to be detected. Okay, that's because electrostatic forces are very strong. Unlike gravity, electrostatic force is very strong. Okay, enough in this case for the balloon to be pulled over to it. Okay, now an interesting thing happens when I bring the balloon over to the wall. See, and what you'll notice is, and I really like how they did this here, the negative charge on the balloon, what it's doing is it's repulsing the negative electrons in the wall. Now the wall's a poor conductor, so what's happening is that electrons don't get very far, okay, but they do get pushed away, okay. Now it's a bit exaggerated as well. They probably get pushed maybe about that much, but that's enough to make the wall positive. Okay, and that's why the balloon will stick to it, because the balloon has a negative charge. Okay, now the wall is neutral. The wall hasn't gained or lost electrons, and the reason why there's no discharge with the touch, there's no charging by contact, is because the rubber and the wall are poor conductors of electricity, and the charge will not transfer well that way. Okay, if you want them to, if you want an electric shock, then what you'd need to do is touch maybe something metal, or if you like a wet cloth on the balloon will discharge it, something that is a better conductor of the electricity to remove that excess charge. Okay, so anyway, this is called charging by friction when I rubbed it with the sweater here, and this is charging by induction actually, where as the balloon gets close without physically touching, that's what basically induction means. Okay, so without direct contact. And what's happening is it's pushing the electrons away, inducing a positive charge at the wall near the balloon. Okay, so anyway, that's static electricity. Okay, now we're going to I just wanted to show you this. It's all, notice the positive charge in solids, in solid objects, the positive charge can't move. Okay, now in liquids and gases, that's not true. The positive charges can move in liquids and gases, but in solid objects, positive charges cannot move. Okay, that's the same thing here. Okay, so solid objects is in the positive charges are in the nucleus, and the nucleus is not going anywhere in a solid. Okay, and the positive charges contained in that nucleus can't be removed or extracted from the nucleus without a nuclear reaction. So that's not going to happen by rubbing balloons around. All right, so that's it for this demonstration. Now we're going to get to the notes. Okay, so I'm going to make a separate video for that.